Hello everyone, welcome to our quick math revision session with Mr. Mpundu. Now in our quick revision session for today, we are interested in additional mathematics. Specifically, we want to revise the 2015 October additional mathematics paper 1, question 12. It was under secular measures. So that's the question we want to look at, the question that you can see on the screen. But before I go into the details, let me say shout out to a good friend of mine, Raul Monga, from Kaunda Square Secondary School. So he asked me to work out this question. Okay, so how was this question supposed to be worked out? As we always do, let's read the question together, analyze it, understand it, then we see how it was supposed to be worked out. So before you understand the question, you won't be able to answer it. So it's all about understanding the question. When you understand the question, you see that it was actually easy. So the question read, in the diagram below, so let me just bring up my pointer. Yeah, the question read, in the diagram below, ABE and BCE are sectors of circles with centers at A and B, respectively. The radius of sector ABE is 8 centimeters and angle BAD equals 2 pi divided by 9 radians. Full stop. Angle ABD is equals to angle ARE, which is equals to 90 degrees, and ED equals 2.44 centimeters. Okay, so this is the diagram. The question that was asked was calculate the area of the shaded region. Calculate the area of the shaded region. 10 marks for that question. Let's study the diagram and then see how it's supposed to be worked out. So the question has told us to say A, B, E. So this part is a sector. Also, B, C, E, this region here, they've told us is also a sector. They've told us these sectors have centers at A and B, respectively. So remember what this means. A is the center for the sector ABE, and then B is the center for BCE. That's what this is telling us, the respectively. Then the radius of the sector ABE is 8 centimeters. So that is AE, that's the radius. And also AB, that's the radius. So AE is equal to 8 centimeters. AB is also equal to 8 centimeters because it's the radius of the same sector. They've given us further information, ED, which is 2.44 centimeters. There is ER, which they have told us the angle ERA is 90 degrees, also ABD is 90 degrees. There is also part C there. Part C is on the line BD, so that's the point, it's part of the sector BCCE. Okay, nice. So this is the question. How do we calculate the area of the shaded region? So basically, we need to first isolate the portion which is shaded. We need to isolate the portion which is shaded. How do we isolate it? And why do we need to isolate it? So only when we isolate the shaded region, we are going to know how we are going to work out the question. Or how are we going to work out this shaded region? So let's identify where the shaded region is found. Which portion is the shaded region found? Under secular measures, the principles are basically the same. When you are told to find the area of the shaded region, the principle is that identify where the shape where the shaded region is found, and then subtract the unshaded part. So it's the whole region or the whole shape where the shaded region is found minus the unshaded part of that region where the shaded region is found. What do we mean? Let's move to our next page and try to put meaning to what we are trying to say. Okay. So here we can move to our next page. So in our next page here, look at the diagram. I have tried to extract a portion from the whole diagram that is obtaining the shaded region. And when you look at that shape from this extraction, so I have this extraction here from the whole diagram. So there is this extraction from the whole diagram. What is this extraction? This extraction is simply the sector B. So that's the sector B, C, and E. We have extracted this sector. So there is this sector BCE from that whole diagram. This sector BCE. The sector BCE is what is having the shaded part. But there is this other part here which is not shaded from the sector, the same sector BCE. Okay. So we know that for us to calculate the area of this shaded region, we know that the formula is simply going to be, so let us write down the formula. The formula will be area. So we are going to say area. This area is for the shaded region. It is going to be equal to, we are going to say area 1 minus area 2. This is what I was saying. When you are dealing with areas of shaded regions under circular measures, all we do is find the area of the whole object holding the shaded region minus that portion which is not shaded in the portion that is holding the shaded region. So in our case here, we are saying area of the shaded region will be equal to A1 minus A2. So we need to know what is our A1. Our A1 is simply equal to the area of the sector. So half theta r squared. This is the area of the sector, sector BCE. So this formula we have written is the area of the sector BCE because the shaded region is in that portion of the diagram. Then, so this is area 1. Then area 2 will be equal to that portion which is not shaded. So when you come to our diagram here, this portion which is not shaded is a segment. This is a segment. Now, a segment from what? A segment from the sector ADE, this sector. So that shaded region which is not, that part which is not shaded in that sector BCE is the segment of the sector ABE, this region which I'm trying to hover around. So that is the sector that we are talking about. But then this sector has got this segment. So now we need to know, how do you find the area of a segment? So the area of a segment, which we have said is area 2, is given by, so area of the segment is given by half r squared, open brackets, theta minus sine theta. This is the area of a segment. Now, both formulas here are having theta and r squared. Let's not confuse the two, theta and also r squared. Let's not confuse them. The first formula A1 has got its own theta, and the second formula A2 has got its own theta. So as we start working out the question, we are going to see the differences. Which theta belongs to which one, which r belongs to which one. Okay. So this is the formula for a sector. How do we obtain this formula for the sector? Let me just break it down. So area of a sector, so this is A2, so not a sector but a segment, is given by, it is the area of a sector which is half theta r squared minus half r squared sine theta. This formula is the area of the whole sector minus the area of the triangle. So in this case here, when you come to the sector ABE, so we find the area of the sector ABE minus the area of the triangle ABE. This leaves us with the area of this segment that we have here. So now this formula that we have, when you carry out factorization, you just say the common thing here is half r squared. That's what we have there. In brackets, you are going to remain with theta minus sine squared. So when you factorize this expression that we can see here. So it's nothing complicated. This is the formula for finding the area of a segment. So it is the area of the sector minus the area of the triangle. When you carry out factorization, it gives us this that we have there. Okay. Now we have identified the formula that we are going to use. Now we come back to the whole question. So let's say this is our solution. Okay. Solution. Now our solution, we need to find A1. We need to find A1. And we've said A1 is equal to half theta r squared, which is the sector BCE. The sector BCE is what we isolated here. This is what we isolated. So now, how do we identify R? How do we identify the theta in that sector? So we know to say R is just BE is R and BC. That's the radius. Then the theta, which we are talking about, theta is just this angle of the sector, that angle. This angle is the theta we are talking about. So we don't know this theta, and we also don't know the radius. So it means we need to calculate the radius over the sector BCE and also the angle of that sector BCE. That's what we need. Let's begin. How do we find the angle? So we know to say theta. Theta is equal to, so theta, when we come to the diagram here, so when you come to this main diagram, when you come to the main diagram, the theta is here. Now what do we have here? The whole angle ABE is 90 degrees. So we need to know the angle ABE. So sorry, ABD is 90 degrees. So we need to know the angle ABE. 90 minus this angle will give us this angle because this is 90 degrees. So when we subtract this angle here, we are going to remain with this angle at this point, the angle we are looking for, or the theta we are looking for. So our theta here, we are saying theta will be equal to the angle BD, this angle, minus the angle ABE. That's what we are going to have. Now we already know the angle ABD, that's 90 degrees. But remember, we are dealing with radians. The question told us it's 90 degrees, but here we are under secular measure, so we are dealing with radians. We are going to have pi divided by 2. That's the angle BABD. It's already given. Minus, what is the angle ABE? We don't know it. That's the question mark I've put there. We don't know it. And it means we have to calculate it. So let us calculate that angle, ABE. So ABE. How do we find the angle ABE? So that angle, we can extract it from the triangle ABE, this whole triangle ABE. Now this triangle is an isosceles triangle. This is an isosceles triangle. And because it's an isosceles triangle, it means the two base angles, this ABE and AEB, are equal. Those are the principles of an isosceles triangle. And that means that when we come here, we are going to say, if this angle here, we say this is x, and this other angle here is also x, because they are the same angles. So we are going to say x plus the angle 2 pi divided by 9 should all give us pi radians. Or in other words, you say 90 degrees. But in additional mathematics, when you're dealing with secular measures, we deal with radians. So we are writing everything in radians. So x plus x is just going to give you 2x is equal to pi minus this 2 pi divided by 9 comes to the other side. It becomes negative. So minus pi divided by 9. So this is going to give us now 2x is equal to pi minus 2 pi over 9. You are just going to get 7 pi divided by 9. That's what we are going to get. Then you are going to divide both sides by 2. Okay. So we are going to say we are going to divide both sides by 2. So this is going to give us 2x is equal to 7 pi divided by 9. So we are saying divide this side by 2. Then also this other side divided by 2. So the 2 divides. Our x is going to be equal to, when you divide those two, you are going to get 7 pi divided by 9 multiplied by 1 divided by 2. Remember, this is over 1. When you introduce a multiplication sign, you switch. Numerator becomes the denominator. Denominator becomes the numerator. And therefore, our x, which is equal to ABE, that's the angle ABE, will simply be equal to 7 pi divided by 18. That's what we are going to have. So this is our ABE. And then when we come to our formula, which we had highlighted here, we said our theta is equals to ABD, which is our theta will be equal to ABD minus ABE, which we wrote here. What we are remaining with is ABE. We didn't know, that's why we put a question mark. But here we have calculated our ABE. It is 7 pi divided by 18. So meaning our theta is going to become theta will be equal to pi divided by 2, pi divided by 2, which is the 90 degrees, minus 7 pi divided by 18. When you simplify this, you do the addition or subtraction of our fractions. After you carry out those subtraction, you're going to get, so the common denominator there is 36. 2 into 36 is 18. Sorry, 2 into 36 is 8. Then 8 times, what am I saying? 2 into 36. When you divide 2 into 36, what do you get? Hey, mathematics is leaving my head. Okay, 2 into 36, you get 18. 18 times theta, you are going to get 18 theta. Minus 18 into 36 is 2. By that, you're going to get 14. Pi, sorry, not theta. Which is equals to 18 minus 14, you get 4 pi divided by 36. And therefore, our theta, when you simplify this, you're just going to get pi divided by 9. Because you divide 4 into 4, it's 1. 4 into 36, it's 9. So our theta is equals to 9. So when we come back to our formula here, remember what we are doing? We are trying to find A1, which is half theta r squared. We have found our theta. We are remaining with r, that is the radius. So how do we find the radius r, which is BC? Let's get back to the diagram. BE, which is the radius of the sector BCE. So BE is the radius, and it's part of the other sector there, or the triangle ABE. ABE is part of that. And remember what we said, the radius of this sector ABE is 8 centimeters. So even here, AB is 8 centimeters. So we have an isosceles triangle, and we want to calculate BE. We don't know what BE is. What do you think we can do to find BE? Or what method can we use to find BE? Or what is the formula? So we are simply going to use the cosine rule. Let's move to the next page. So we are going to use the cosine rule. The cosine rule states that, so let's just come back to the diagram a bit. Okay, so the diagram that we have, the angle ABE, the angle ABE, so we are saying we are going to have, we are looking for that triangle that we have. We say the triangle is this one. So this is ABE. And we said this angle and this angle, they are the same. We know this angle is 2 pi divided by 9. We know this is 8. This is also 8. So these two are equal. These two angles are equal. But now we are not interested in the angles. We are interested in the side, this side BE. Now this side BE is simply going to be represented by the small letter a. This other side will be represented by E. This other side will be represented by B. So the formula that we are going to use, we said it's the cosine rule. And according to the cosine rule, since we are looking for the side A, it will be A squared is equal to E squared plus B squared minus 2EB cos of the angle A. That's the formula. And this is just A squared is equal to E is 8. So it's 8 squared plus B is also 8. 8 squared minus 2 multiplied by E is 8. B is 8. The cosine of the angle is 2 pi divided by 9. That's the formula. When you work this out, you're going to have A squared is equals to 8 squared is 64. 8 squared is 64. 64 plus 64, 128. 8 times 8, 64. Negative 2 times 64, you get negative 128. Then cosine of 2 pi divided by 9. Then this is going to be A is equal to, you simply introduce a square root here to get rid of that square on A. Introduce a square root on both sides. The square and the square root divides. Our A becomes the square root of 128 minus 128 cos of 2 pi divided by 9. That's what we are going to have. So therefore, our A will be equal to, we should develop a skill of key in these figures that we have on the calculator. It's very simple, easy and straightforward. So you just go on the calculator there. If you're using a scientific calculator, type in, if you're using a scientific calculator, open your calculator, make sure it's in radian mode, because our angle there is in radians. You're going to say square root of, open brackets, you're going to say 128 minus 128, then you press cos what? Introduce another bracket there. You type in 2 pi divided by 9, close brackets and close brackets again. That's what we are going to do. Close brackets, close brackets. Then from there, you are going to obtain the solution and press your equals. You're going to obtain your solution as 5.4723 and the like. But ECZ requires us to just round off to 3 significant figures. So we are going to obtain there 5.47. So this is our A. And this A is equal to what? BE, which is the radius of the sector that we are looking for. Remember, we are trying to find the radius of the sector BCE. So remember, we had indicated there to say we have this sector BCE. Now let me just write that properly. So we have the sector. So we have the sector BCE. So we said for us to find the area of this sector BCE, we need theta, which we have calculated, and we need the radius, which is r. And we have just calculated the radius r. Then what is remaining here is for us to find the area. So that's area 1. Area 1 will simply be equal to, half, which is the same as 0.5 times, remember the angle that we found for theta, we said it is pi divided by 9, close brackets, multiplied by 5.47. This is supposed to be squared. That is according to the formula for the area that we had indicated. What is this going to give us? When you type in these figures into your calculator, that's you type in, key in those values in the calculator, you're just going to get A1 is equal to, so that's 1 over 2 is the same as 0.5. So it's just 0.5 times pi divided by 9 in brackets times 5.7 squared, and you're going to get 5.22 square centimeters. Remember, this is the area of the sector BCE. The area of the sector BCE. So we have found A1. We have worked out A1. We are supposed to find A2. We are supposed to find A2. Remember what we said A2 is? A2 is half r squared, open brackets, theta minus sine theta, close brackets. This is what we said A2 is. Now we already know the figures here. Half multiplied by r. What is r? Now, according to the diagram that we said, A2 is coming from the sector ABE. We are trying to find the area of the segment. This segment, so in this diagram here, we say there is this part. There is this segment here, this segment that we are. This is the shaded region. But then this shaded region has got this segment. This segment is coming from this part, ABE. That's where it's coming from. So we are trying to find this area of this segment. This is the formula that we have written here. Now half multiplied by r squared. This is the r and the r. R is 8. So it will be 8 squared. Then open brackets, our theta. Theta of this sector is 2 pi divided by 9 minus sine of the same angle, 2 pi divided by 9. It's the same angle that we are going to use. That's what we are going to have there. Then from there, we are just going to have A2 is equal to, remember, 8 squared. So here we are having 8 squared, which will give us 64. 64 times half. What is 64 times half? So 64 times half is just going to give you 32. Then 32 multiplied by go on the calculator again. So that is here we are having 2 pi divided by 9 minus sine 2 pi divided by 9. That's what we are having. So just go on the calculator, type in those figures. So you're going to say, in brackets, open your brackets, type in 2 pi divided by 9, close brackets, minus sine of, again, you type in 2 pi divided by 9, close brackets, enter. It will give you the answer. That answer multiplied by 32, that 32 which is outside, and our area 2, therefore, area 2 will simply be equal to 1.771010, just like that, but then round off to 3 significant figures, it gives you 1.77 square centimeters. This is A2, or the area of the segment, that segment in our shaded region. And pretty much we have done everything that we need to do. This is just going to give us now shaded area is equal to, remember, it is A1 minus A2. This is going to give us our A1. We are from finding A1 here. A1 is here. A1 is 5.22. A2 is 1.77. Interesting figures, right? Yeah. So A1 is 5.22 minus 1.77, which is going to give us, when you subtract those two figures, you are going to get 3.45 square centimeters. This is the area of the shaded region. All we have done is what is going to earn you 10 marks. Interesting question. Now, let's get back to the question and the diagram. Remember in the diagram that we were given. So the diagram had the length ED. The diagram had the length ED. When we go back to our question, the diagram had the length ED. Our ED was given as 2.44. From what we have done to find the area, was ED necessary in the question? The answer is simple and straightforward. Not at all. Because we have not used it anyway to answer the question. Let's go to ER. There is ER given in the question. When you look back at the question, there is ER that has been given in the question. Is ER necessary? Not at all. How have we used ER in working out this question? Not at all. What does that tell you? Sometimes ECZ is going to make a question for you. Try to make it as complicated, to look as complicated as possible. But then, there is nothing at all in that question. ECZ will try to make the question look as complicated as possible. Add clusters to the question. Too many unnecessary information in the question. But then, you don't even need it. So how are you going to know what you need and what you don't need? Simple thing. Identify the region which is holding the shaded part. When you identify that region, like we identified in our case here, that region which was holding the shaded part was the region BCE, which is the sector BCE. We need to say that sector is having the shaded region and the unshaded region. So check out, what's the formula for the whole shape? So area of a sector, we know the area of a sector. What is the unshaded part? It's a segment. How do we find the area of a segment? We know how to find the area of the segment. But the question did not give us the radius. So the question did not give us the radius of the sector and also the angle of the sector. So the only thing that was required is for you to get to calculate the angle theta and the radius of that sector that was holding the shaded part. That's the only thing. The rest of the things were just clusters to confuse us or to make us feel intimidated that the question is probably difficult or something complicated. Otherwise, this question was straightforward, simple, and something workable to everyone. Now, what I've noticed is that many pupils want to think it's difficult to deal with radians. It's not difficult. Like we can see, we've seen in this question, we have answered this question with radians alone. We have not touched degrees. So people waste time by trying to convert the angles given in the question to degrees, and then after they finish working them out, try to convert them back to radians. It's some tedious process. Some process that is going to make you waste a lot of time in the exam. So avoid doing all those things when you're working out questions in radians. All you have to do is change your calculator, put it in radians. Be friendly with, be familiar with fractions. Work out those radians with fractions, and also having a skill of using a calculator. You've seen how we have used the calculator in answering this question. If you don't have that skill, even if you write the correct thing, you understand the question, if you don't have the right skill to use the calculator, you still make mistakes and fail the question. If not, you are going to waste a lot of time because you'll be typing in one by one. You type in 2 pi divided by 9, press equals, find the answer, write it down. And also you have to round it off because it will give you a decimal. And all the time you are rounding off the solution, it means you are reducing the accuracy of the final answer. So we want to avoid doing all those things. Master the skill of using the calculator whenever you are dealing with these questions. And it's a very cardinal thing in additional mathematics, because even in other topics, you still need to know how to use the calculator well. Anyway, let me not say much and take out the knowledge that we have shared in this question. Let's end here. Let's look forward to the next question. Feel free to ask any question that you want. We are going to make time for you and see how we can work it out. So Raul, that's how that question was supposed to be worked out. I hope you understand and share with your friends, and also feel free to ask any other questions. Otherwise, it was good discussing this question, an interesting question with you guys. And we want to say we end here. Remember to subscribe to my YouTube channel, follow my Facebook page so that you don't miss out every time I post an interesting video like this one, so that we can revise together, share with your friends so they can also benefit from this video. Let's try to, for now, we've just started our channel. Let's try to reach the 100 subscribers. When we reach 100 subscribers, we can start live videos so that we can join in and discuss these questions live, where you also be having an opportunity to ask questions and then also benefit. And also, our online classes are on. Feel free to join the online classes. Reach out to me on my WhatsApp line. Reach out to me on a direct call. My numbers are readily available. My WhatsApp line is very, very easy. Very, very easy. Let me write it down here. 0950 555. Sorry, not 555, but 55 2200. 0950 55 2200. This is my WhatsApp line. WhatsApp. Feel free to reach out to me for those online tuitions. We'll be able to enroll you, and then you will benefit from this work. For now, it's bye-bye. Enjoy your evening.